They say about 1 in 10 people are probably hypothyroid. Like, what do you think it is in actuality with everything that we're exposed to, if you had to give a ballpark estimate?
The figures that you tend to see around about anywhere from 2%, sometimes 5%. In India, there's an overall kind of prevalence of about 11%, and the suggestion behind that is endocrine disruptors. I think if you look at it realistically and you look at, say, entertained subclinical hypothyroidism, I think you're getting a decent figure of 10 to 20%, and possibly even more, bearing in mind that the gold standard of how it's assessed, TSH with T4. Depending on who you talk to, if you're an endocrinologist or medical doctor, that's the gold standard. I think when you dig into it a little bit deeper and see all of the mechanisms of function that can make TSH output and the sensing of negative feedback problematic, then you kind of could get a better idea that there's certainly more. So it becomes difficult to put a figure on it, but my feeling is somewhere between 10 to 20% of the world's population, possibly even more. The more that we start seeing increased stressors, increased endocrine disruption, I think that's probably likely to be, getting higher. And also, when you start altering TSH set points, which can happen during the gestational period, depending on what the offspring or fetus is being exposed to, you're kind of getting a whole world of problems there. So I think it's increasing. I think you just have to look at the increases in other diseases like cancer, hypercholesterolemia, hyperglycemia, metabolic syndrome, instead of just kind of looping these in and saying, oh, these individual diseases. It's probably a reflection of the increasing low. People could be presenting as low thyroid. People can have issues in winter, which could be low thyroid. Again, it could be, a light deficiency. There could be many things. But I think the more that we're seeing broad spread, creeping in of chemicals within the food chain, within the water, within the air that we breathe, potentially electromagnetic stresses, this could be increasing it and making it harder to detect.
Absolutely. And so the emphasis of that is that it's probably drastically underdiagnosed compared to what the medical literature says.
Yeah, for sure.
How would you define subclinical hypothyroidism?
Well, again, in the textbook, it's usually just an elevated TSH, which would usually be somewhere above the, I think the general markers is about 4.5 to 5 MULs is the measurement. Usually the reference range is somewhere around about 0.5 to 4.5 or 5. Subclinical hypothyroidism is an elevated TSH above that, with usually a normal or low T4. And again, I think that becomes problematic when we're looking at that as well. And as many kind of older researchers looked at and who kind of paid the price, is that it can take a long time for the TSH to creep up. And as we know, there can be certainly many confounding factors that make the TSH look problematic, whether it's, you're going to the doctors and you're kind of having your TSH assessed, but if they're not checking how much you're eating, for example, how much stress you're under, how much exercise you're doing relative to nutrition intake, then that TSH is going to be problematic, because we know that fasting and malnutrition decreases TSH output and can render you hypothyroid without actually being able to diagnose it properly. So these are the things that I think you need to consider. So, but going back to subclinical hypothyroidism, again, that is generally the marker, is an elevated TSH, mildly elevated TSH. And I think that's when you would start to look at other indicators that might give you, an idea, and they can come out in cholesterol values, in a CBC. Certainly the cruder evaluation of temperature and pulse would be a good thing to look at. There are potentially other markers in there, hypertension, hyperglycemia, that could be looked at as part of that, and even other things beyond that, such as liver enzymes or other factors that you could look at there. But it's not always set in stone. It's not a linear picture. You don't see all these magic buttons going off, going high cholesterol, hyperglycemia, hypertension, all the things at once. It can be depending on the output, where the disturbance is, and this is why my particular belief, what I'm really challenging with the research, is the idea that if you don't understand where the blockage is occurring, which could be disruption of the carrier proteins, such as thyroid binding globulin, transthyretin, human serum albumin, which all can be hijacked by a variety of pollutants. And then you have the transmembrane transporters, which are your monocarboxylate transporters at 8, 10, your OAT1 PC1s. These are kind of your specific transporters that would take thyroid across into the cell where the deiodinases will work. And if the deiodinases are disrupted, and then specifically with certain chemicals, how they bind to the thyroid receptor, which can give you an agonist or antagonistic response, depend on how the binding forces work within the DNA binding domain and the ligand binding, how that all kind of interacts together. So if you're not aware of all those things and you just think TSH, negative feedback, then you're kind of blinkered to the idea of how the thyroidal system works, because it's vast and it can be disturbed at many different levels.
In other words, to try and simplify that for the listener, that would basically be saying that, TSH, thyroid stimulating hormone, goes up as thyroid production goes down. So it's trying to increase thyroid production. But there's a bajillion different things that can get in the way of the thyroid actually making it or being produced in the first place in the thyroid, or getting it to the cell, getting it in the carriers. And a lot of those are endocrine disruptors that we're being exposed to in our environment, among other things like, as you said, potentially EMF, like Wi-Fi and cell phone, and even your couch covering.
Yeah, the brominated flame retardants, which are the most common. Well, they're one of the most common findings in household dust.